The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone, welcome. My name is Nathan, otherwise known as Old Man Bills. Guys, thank you for joining me today. Sean's out, he had a surgery and he's recovering, so he'll be with us next week. But I'm going to be here and Joe's going to be here. We're going to be talking a little cold energy with Peter Lindemann. So I'm going to go ahead and get it started and bring that up right now. It's a really cool lecture, guys, if you haven't seen it, and then we'll stop in between. We'll talk a little bit about it, do some interaction with the chat, and it should be pretty cool. Well, that was the wrong one. All right, here we go.
Ever since I learned about the work of Edwin Gray, more than a quarter of a century ago, I have been trying to understand how he obtained free energy. Only recently did the necessary information become available that allowed me to finally summarize all the clues and reach a definite conclusion. In the Free Energy Secrets of Cold Electricity, I describe this 27-year odyssey and the knowledge I gained along the way. Edwin Gray discovered that the discharge of a high-voltage capacitor could be translated into a huge radiant electrostatic surge. This burst of energy was generated by his circuit and was captured by a special device that Mr. Gray called his conversion element switching tube. The non-damaging cold form of energy coming out of this conversion tube powered all of his demonstration installations, instruments, engines, and also charged his batteries. Mr. Gray called this process splitting of positive electricity. These names were incomprehensible because Gray did not reveal anything concerning the conditions under which the circuit was operated to produce this effect. It was a mystery. It wasn't until I compared what was known about Gray's work with Jerry Vassilatos's analysis, published in 1996, which detailed Nikola Tesla's experimental work in the late 1880s, that the picture began to become clearer. These experiments led to the discovery of what Tesla called radiant energy and formed the basis for the subsequent development of his amplifying transmitter. This material revealed Gray's secret. A careful comparison of Gray's cold electricity systems and Tesla's radiant energy systems led to the well-reasoned conclusion that these two discoveries were in fact one and the same. In light of this, it was finally possible to correct Gray's circuit diagram and complete all the gaps in it. I believe that this book contains enough information that anyone interested in obtaining free energy can reproduce the effects of cold electricity using fairly simple equipment. I believe that thousands of engineers and experimenters will begin to replicate the effects of this main channel of free energy. Many people have provided invaluable assistance during the course of my research, and I would like to thank them and express my gratitude. Tom Valentine, for his persistent research into the history of Edwin Gray, for his excellent and careful answers, for the...
What's up, Joe?
Hey, what's up, Nathan? What's up, everybody?
What's going on,
Apologize
man?
for my tardiness.
Don't even worry about it, man. Thank you for coming in.
Yeah, of course.
Dude, we're talking a little cold electricity. We already heard that Tesla's talked about radiant energy, which is awesome. And then Edwin Gray and his circuit, which has to do fully with radiant energy. And we're just going to start getting into the good part after Lindemann start talking about everyone saying hello. You know what I mean?
Yeah, awesome. Well, I'm here for it.
Right on, man. Well, let's get this rolling a little bit.
Unusual ways in which he obtained photographs, and for the amazing generosity with which he made his entire archive available to me. I wouldn't have discovered anything without his help. Eric Dollard, for being the first of our contemporaries to truly understand Nikola Tesla's work with pulsed discharges, and for redemonstrating this work using special apparatus. To Jerry Vassilatos, for so brilliantly explained and neatly compiled for publication the history of Tesla's discoveries, and to David Hatcher Childress, the publisher of Jerry's book, for giving me unusually broad permission to quote from it. Then, to Bruce De Palma, for teaching me how to think about physics the way things really exist.
Jeez, it's
Trevor
all the big
Constable,
names, huh?
for disabusing me of any confusion regarding the
inspiration.
existence of the ether, and for his tireless efforts in its practical application for the benefit of mankind. Tom Brown, for introducing me to many of these people, and for expanding the horizon of my knowledge in countless areas. Allison Davidson, for permission to reproduce here a color photograph of an etheric discharge in an amplifying transmitter by Eric Dollard, taken from Integration Magazine, Summer 1986 issue. Dorothy O'Connor and Jacqueline Lindemann, for their contributions to the editing of this book. And finally, of course, to Edwin Vincent Gray Sr. and Dr. Nikola Tesla, who discovered this amazing technology.
Peter A. Lindemann, Ph.D., December 2000.
When the great truth is suddenly discovered and experimentally confirmed that this planet with all its awesome immensity of electrical charges is in fact scarcely more than a small metal ball, and when from this will follow vast possibilities, each of which is amazing and has innumerable uses that will be fully exploited. When the first plan is adopted, and it shows that a telegraphic message is almost as secret and undetectable as a thought, and can be transmitted to any distance, when the sound of the human voice with all its intonation and expression will be accurately and instantly reproduced anywhere on the globe, when the energy of falling water is available to provide light, heat, and movement everywhere, on the sea, on land, or high in the air, then humanity will be like a torn-up anthill. Everything will be in turmoil.
Nikola Tesla, 1904. Chapter 1. The Mystery
Little
of Edwin
premonition there, huh?
Gray.
My interest
Oh, dude, yeah. This whole thing was the greatest because he goes into like Tesla and into Edwin Gray and explains the radiant energy of Tesla different from the radiant energy patent Tesla filed. And then he goes into the, oh man, what was it? The hairpin circuit, and exactly how it ties in to what Edwin Gray was doing and why that was the radiant energy Tesla was talking about. Dude,
All
it's
right,
like,
cool.
it's right in line with everything we talk about.
Yeah, it sure sounds like it is. Yeah, man.
in free energy began in the summer of 1973, when I first read the National Tattler, article by journalist Tom Valentine Figg. One first article from National Tattler was entitled as follows: Inventor creates an engine that does not consume fuel. This invention could change history since 1984.
Nice.
Although I was young and impressionable, I had never seen a headline like this before. The article began with the following words: A California inventor has found a way to produce unlimited amounts of electrical energy without using fuel. Potentially the greatest discovery in human history. Edwin Gray Sr., 48, has created working devices that can forever power any car, train, truck, or boat, and the airplane in this country, to heat, cool, and service every American home without laying transmission lines, to supply an endless amount of power to the nation's mighty industrial system forever and ever, all without breaking a sweat. Environmental pollution. After several paragraphs about capital growth and job creation, the article described two very interesting tests that the author, in the company of several scientists, had witnessed in Gray's laboratory, which was located in Van Nuys, California. Tatler received a complete demonstration of impossible but real Gray's methods for using electricity. The first demonstration showed Gray using an entirely different form of electrical charge, a powerful but cold form of energy. A 6-volt car battery rested on the table. Connecting wires ran from the battery to a bank of capacitors that are the key to Gray's discovery. The whole system was attached to 2 electromagnets, each weighing 570 G. Now, if you try to connect these 2 magnets from that battery and do what I'm going to do with them, you will drain the battery in 30 minutes, and the magnets will become extremely hot, Gray explained. Look what happens. When Fritz Lenz connected the battery, the voltmeter needle gradually reached the 3,000-volt mark. At that moment, Gray closed the switch, and there was a loud bang. The top magnet shot into the air with great force and was caught by Richard Hackenberger. A terrifying jolt of electricity sent the top magnet flying more than 2 feet into the air.
He
But
caught
the
the thing
magnet
midair?
remained cold. The amazing thing.
Say it again?
I said, he caught the thing midair?
Yeah.
I thought he just did one
That's
of those
pretty slick,
shots,
huh?
like a can falling out of the cupboard sort of deal.
Yeah.
And it was cold.
So what's cool about this is they're describing cold energy going into a capacitor, yet the capacitor is still hot when it builds up the energy when he discharges the capacitor. So, which is 100% true. We've all done it.
Said Hackenberger, is that only 1% of the energy was used. 99% went back into the battery. Gray explained. The battery can last a long time because most of the energy is returned to it. The secret to this process lies in the capacitors and the ability to separate positive electricity. When Gray said, separate positive electricity, the faces of the 2 famous physicists stretched out in bewilderment. Normally, electricity consists of positive and negative particles, but Gray's system allows you to use only one of them separately and with high efficiency. Tom Valentine then explained the second demonstration shown on Fig. To Edwin Gray demonstrates his chain. Gray showed the Tatler reporter a small 15-amp-hour motorcycle battery. It was connected to a pair of his capacitors, which in turn were connected to a panel on which the electrical sockets were mounted. He pressed the switch, and the tiny battery sent a charge to the capacitors. He then plugged in 6 15-watt light bulbs on separate wires, a 110-volt portable television, and 2 radios. The lights were bright, the TV was working, both radios were talking, but the small battery was not draining. You wouldn't be able to get the same amount of current out of this battery under normal circumstances, Gray said. This is the most amazing thing I have ever seen, exclaimed K.V. Wood, Jr., president of McCulloch Oil Corporation, who was also present at the demonstration. He started looking for hidden sockets on the walls. I can prove that the power is not coming from other outlets, Gray suggested. He took a 40-watt light bulb on a regular extension socket and connected it to a panel powered by his system. You can see what happened next on Fig. 3 Tom Valentine, with a cold, glowing lamp in water. The light bulb lit up, and then Gray threw it into a cylinder of water. What would have happened if ordinary energy had been used here? Gray asked, and plunged his hand into the water in which the light bulb was glowing. You would have been electrocuted. There would have been a pop and a hiss. and it would continue as long as at least one of your fingers touched the water. But there is no shock. Gentlemen, this is a new manifestation.
Okay, so we're in cold electricity, right? There's no doubt. So you put anything in water like that, it's got to be on the opposite side of it. Can't be on the hot side. It's got to be on the cold side. So he perfectly explained what was going on there and the fact that you could separate the hot and cold sides. So it makes all the sense in the world if you understand a free energy circuit.
Of electricity, said Hackenberger. This was perhaps the most amazing article I have read in the newspapers. I was completely engrossed in this. A few weeks later, I found the second article in the series. Fuelless electric miracle could save $35 billion a year in gas prices. Figured 4 second article from the National Tatler. It talked about an amazing new type of electric motor that was powered by Gray's system. The silent, non-polluting electromagnetic motor recovers the energy expended in it and can operate indefinitely. Gray's prototype runs on 4 6-volt batteries, which are more likely to wear out than they will be discharged. The same repelling magnets on cold energy located on the rotor activate engine. Hackenberger, an electronics specialist, explains, our circuit produces a series of high-voltage pulses of energy. These portions of energy are transferred to a control device, which acts as an ignition distributor in an internal combustion engine. Each time the magnet is charged, most of the energy is returned back to the battery without loss. Around the same time, another article appeared in the magazine, Check the Unknown. The article was called The Motor That Powers Itself by Jack Scagnetti, provided much of the same information that was contained in Tom Valentine's articles, explaining the principle of his motor in the same way as the return of energy from light bulbs. Richard Hackenberger, Vice President of Engineering at EVG Ray, explains how an electromagnetic motor works. The energy from the high-voltage section, moving through the electrical circuit system, produces a series of high-voltage energy emissions. The emissions are transmitted to the control unit, which operates the main engine in turn. When this happens, the regenerating system recharges the battery with pulses of 60 to 120 amps. These articles have completely captured my imagination. Shortly thereafter, my brother and I wrote to A.V. Gray Enterprises, Van Nuys, California, expressing our interest and wanting more information. I received the following letter in October 1973. Dear Mr. Lindemann, I am pleased to thank you for your great interest in E.V. Gray Enterprises, Inc., and for the time you took to write to us. I also sent a letter to your brother, but following our privacy policy, we cannot provide you with information about our engine or company. Needless to say, it was quite discouraging. So I reluctantly put Valentine's and Scagnetti's articles, along with the letter from E.V. Gray, into a folder that suddenly grew into my very long research on the topic of free energy. Unfortunately, I didn't see any articles about Ed Gray for the next couple of years. In 1977, however, I found another article by Tom Valentine in an issue of Newsreel magazine about classified research. Valentine wrote about various technologies, from extracting oil from coal to making gasoline from water, about planes that don't crash, and other amazing research. The article also included a story about Edwin Gray under the heading EMC, the electronic energy that could change the picture of the global energy economy. Figure 5 article in Newsreel magazine. In this article, Ed Gray said,
I remember getting an electric shock when I picked up a charged capacitor from a workbench. The incident still haunted me. Then I saw government officials testing the first radar on the Potomac River. I remember, as one of the scientists explained the principle of its operation, a pulse is released, a pulse returns, and I was always interested in thunderstorms. I noticed how much more powerful they become as they approach the ground. This process is somehow influenced by a larger amount of air. These three principles, and also top-secret methods for producing and mixing static electricity, form the basis of Gray's electric motor.
Further in the same article, "There is no other engine like this in the world," said Dr. Chalfin. "Conventional electric motors use continuous current and constantly waste energy. In this system, energy is used only in a small part of a millisecond. Unused energy is returned to the additional battery for reuse. It is completely cold," Dr. Chalfin added, placing his hand on the motor. "There is no energy loss in this system." Gray's first patent, issued in June 1975, was entitled Electric Motor, Operating on a Pulsating Capacitor Discharge. I received a copy of this patent in 1978. This rather large patent consists of 18 sheets, 19 illustrations, and 18 claims. It describes a motor that is driven by discharging capacitors through electromagnets positioned opposite each other. But I soon discovered that if you tried to make an engine according to the principles included in the patent, it would not work as described in Valentine's papers. In fact, it will not produce the cold form of electricity at all. If you get in the way of the discharge of these capacitors, you will be thrown to the other side of the room. Moreover, the amount of energy returned is not even close to what Gray talked about in the articles.
Okay, so he's coming up with the conception of running things in hot energy right now, which is running through the positive side, instead of running it through the negative side. So he's seeing the same things in the capacitors, but he's seeing a bunch of loss in it because everything's hot. You know what I mean? He didn't understand the cold energy form. He didn't understand you're pulling through the negative of the battery. We have Gerald's circuit that we always look to. It does the same thing. There's absolutely zero difference in what he's talking about here and what Gray's doing, what he's doing. Different. Gray uses radiant energy in his. It's not static. So, yeah, there's a bit there, but yeah, he's coming with the understanding of, hey, let's put it like normal people do, and it's failing every time.
Right. Yeah, it can't be used exactly the same way. I mean, like I was thinking while he was talking about it, it's at this early stage of the understanding of it that they're going over right now, and they're kind of treating it like if you were to think about an old car, like a purely mechanical car that didn't have like electronics and stuff, right?
Yeah.
You put it into gear, you push it, you spin the wheels, right? And you could start the engine. But usually you start the engine to push the wheels, right? Yeah. So that was kind of like what came to mind with like how they're looking at it in these like initial stages before they really understood what it was they were dealing with.
Yeah. It's hard to get your mind around it at first.
It soon became clear to me that this patent protected a specific engine design, but did not show how it worked. From the very beginning, I was most interested in its solid-state circuit. I found out that the production of cold energy had nothing to do with the motor, and that the motor was only a secondary device. After all, when Gray threw magnets and turned on the TV and light bulbs, he was not using a motor. Intuitively, I knew from the very beginning that the key to unlocking the secret of Gray's discovery lay in attempting to fully understand the workings of his solid-state circuit. However, the sources I used for this were far from perfect, and by the late 70s I had absolutely all the information available on the topic. At the end of the 1980s, I had only heard rumors that Gray was continuing his work, but all I could find out was that there were no new articles or other messages about him. In the mid-1990s, however, a colleague of mine said that he had heard that Gray had received several more patents, and this intrigued me greatly. Do these patents answer the questions I was looking for? I didn't know this exactly, but I knew that I needed to have these documents. Unfortunately, my colleague did not have them, and did not know their numbers. So once again, my investigation into Ed Gray's cold electricity stalled for several more years. In June 1999, while visiting the IBM Intellectual Property Network on the Internet, now called the Delphi Intellectual Property Network, I noticed that the patent database search engine had recently been updated to allow searching by inventor name. By typing Gray into the search bar and examining every word in every patent since 1971, you will get so many results that you probably won't be able to look at them all. Now, in the updated machine, I was able to enter Gray, Edwin. And so, after 30 seconds, the numbers of the remaining 2 patents, received by Edwin Gray, appeared on my screen. I was in 7th heaven on Rice. 6 Gray's chain patent, the first of these patents, is shown, entitled Energy Enhancement Apparatus, Suitable for Inductive Loads, issued in June 1986. Understanding this patent is the basis of this book. Another patent was entitled Efficient Electrical Converter Switching Tube, Designed for Inductive Loads, Figure 7 Gray's Conversion Tube Patent, and was released approximately 10 months later, in April 1987. These 2 patents are closely related and almost identical. One of them describes the circuit that operates the switch tube, and the other describes the tube itself. Almost 80% of the descriptions in these patents are identical. Fig E. 8 Gray circuit diagram. Shown here is the circuit diagram from the first patent. I've been looking for this diagram for 26 years, and finally I have a chance to understand what Gray was doing. I was sure that I was looking at the basis of his circuit of cold electricity, but Gray still kept his cards close to his chest. Looking at this diagram, it is not clear how these components behave, or what they do, and why. The more I studied the text, which was quite short compared to the engine patent, the more I realized that I was looking at something completely incomprehensible to me. Intuitively, I knew that I had all the pieces of the puzzle, but I still didn't know how to put them together, much less what the finished picture would look like. How can this circuit produce free energy? There was still too much that was unclear. However, I was impressed by some of the interesting references in these patents. For example, in one small paragraph, Gray points out, hidden here is an electrical control system which, in theory, converts electrical energy from a low-voltage source, such as an electric battery, into high-potential, high-current pulses that are capable of producing a force action on an inductive load more efficiently than that produced directly from the energy source. This statement may sound a little confusing, but as I found out, it was just a dodge to avoid saying the words free energy. He further states, this system achieves the result stated above by using electrostatic or pulse energy, created by a high-intensity spark generated inside a specially designed electrical converter switch tube. This tube uses a low-voltage anode, a high-voltage anode, and one or more electrostatic charge-receiving grids. These grids are specially sized and arranged in a special way to fit into the tube, and therefore directly correlated with the amount of energy expected when the device is operating. The further I read into this patent, the more intrigued I became about components, NOSN 42, 44, and NUM 46. The patent states, a spark gap protection device, 42, is included in the circuit to protect the inductive load and rectifier elements from excessive discharge currents. In the event that the potentials in the circuit exceed predetermined values fixed by the mechanical size and air gap of the arrestor, the excess energy is dissipated, removed, by the protective device into the common circuit. Electrical ground. Diodes 44 and 46 remove excess energy generated during trigger switching of the converter element switching tube. So in this circuit, we see 3 elements, NOS 42, 44, and 46, which are specially designed to dump excess energy when this tube is lit. It follows that it is possible to produce so much energy here that it could damage the rest of the circuit. This was very promising, but I still did not understand what kind of phenomenon could create such conditions, or why. But it was absolutely clear to me that Gray was expecting something extremely huge that happens when the converter tube burns. I was convinced that I had discovered the secret of the device, but I still didn't really understand what I...
Okay, so what he's dealing with right there is the field flip.
Mm-hmm.
He's pulling a radiant field in. It's filling up the whole tube, right? And then he's got to cut it hot. So as soon as he puts a hot element in there, it immediately turns a whole entire bunch of energy that's in there and turns it directly into current.
Right.
And it just blasts through the system. So he can overcurrent the whole thing in no time if he doesn't dump some of it.
Well, that the visual that I was kind of getting in my head when he was describing that part was actually like one of Sal Paez's patents, where he has like the four. I mean, I was thinking of them more as transducers in other contexts, but in this context, he had like 4 inward-facing spark gaps, to a center node that you could just pick up the energy on too. So, like, something like that kind of just popped into my head when he was describing it.
Yeah, he's using the spark gaps in the system like an energy break.
Yeah.
Like go through one side like a diode, but no diode that we know would handle this. So
right.
He's got to use spark gaps instead.
Yeah.
So
that would make sense. And you have 4 of them potentially for like hot and cold to spark over.
Well, he's got one going through one side, one going through other. So there's 2 in the Edwin Gray circuit, but the other one is in your amperage tube that goes in the center. So there's a tube, 2 tubes sitting like this, a little bit of spaced apart. It's fully for amperage right there. And it's for cold current amperage is what it is. That it looks like a spark gap, but it isn't. So, all right, we'll keep playing it.
I was seeing in front of me. I needed a Rosetta Stone, something that could translate all these mysterious writings into understandable text. Luckily, I found it. The Rosetta Stone was a book called Secrets of Cold War Technology, The HARP Project, and What Behind It, written by Jerry Vassilatos in 1996 and published by Adventures Unlimited Press. In the first chapter, entitled Nikola Tesla and Radiant Energy, Vassilatos returns to the heady days of 1890, when Nikola Tesla conducted experiments that led to the creation of a magnifying, amplifying transmitter. This is an amazing piece of work, and I recommend purchasing and reading the entire publication. However, to add to all the merits of this book, the following excerpts from the first chapter not only describe the most interesting history of the discovery, but, more importantly, provide the basis for a complete understanding of Tesla's amazing amplifying transmitter, and then its connection with Edwin Gray's cold electricity circuit. Edwin Vincent Gray, 1925 to 1989. Edwin Gray was born in Washington, D.C. in 1925. There were 14 children in his family. At the age of 11, he became interested in the then-emerging field of electronics when he observed one of the first demonstrations of primitive radar on the Potomac River. At the age of 15, he left home and joined the Army, attending the Army Engineering School for 1 year until he was discharged due to the discovery of his insufficient age. After the attack on Pearl Harbor, he was reinstated in the Navy and served on the Pacific battlefield for 3 years. After the war, he worked as a mechanic and continued his research in the field of electromagnetism. After years of experimentation, he discovered how to separate positive electricity in 1958 and created the first prototype of his EMA motor in 1961. EMA Electric Magnetic Association. The third prototype of his motor was successfully tested for 32 days and then was disassembled for analysis. With these results in hand, Gray began searching for funding sources. After being rejected by all the major corporations and venture capital firms, he formed his own limited liability company in 1971. By early 1973, E.V. Gray Enterprises, Inc. had an office in Van Nuys, California, hundreds of private investors, and a new, fourth, prototype of the EMA motor. Ed Gray also received a Certificate of Excellence from Ronald Reagan, then Governor of California. In the summer of 1973, Gray conducted demonstrations of his technology that received rave reviews in the press. Later that year, he joined forces with automobile designer Paul M. Lewis to build America's first fuel-free electric car. But then trouble happened. On July 22, 1974, the Los Angeles District Attorney's Office raided the offices and store of E.V. Gray Enterprises without warning and seized all business papers and working prototype engines. For 8 months, the district attorney tried to force Gray's shareholders to testify against him, but none of them agreed. Gray was unexpectedly accused of grand theft, but even this false charge was eventually dropped. In March 1976, Gray was charged with 2 minor violations of Securities and Exchange Commission regulations, but was acquitted and released. But the Los Angeles District Attorney's Office never returned the prototypes to him. Despite this, there were also positive developments. His first U.S. patent for a motor design was awarded in June 1975, and in February 1976, Gray was nominated by the Los Angeles Patent Attorneys Association for Inventor of the Year for his discovery and proof of a new form of electrical power. Despite this support, Gray received significantly less funding from this time on. At the end of the 1970s, Gray's technology was bought up by Zetec Incorporated, and E.V. Gray Enterprises ceased to exist. In the early 1980s, Gray offered his technology to the American government to implement the Reagan SDI program. He sent letters to every member of Congress, both senators and members of the House of Representatives, as well as the President, Vice President, and every member of the cabinet. Surprisingly, in response, Gray not only did not receive a single answer, but not even a single notification that the letter had been received. During the first half of the 1980s, Gray lived in Council, Idaho, where he filed and received 2 more of his patents. In 1986, he took out a loan and bought a workshop in Grand Prairie, Texas, where he created several more new EMA motor prototypes. By 1989, he was working on applying his technology to propulsion applications and established a residence in Council, Idaho, and workshops in Council, Grand Prairie, and Sparks, Nevada. Edwin Vincent Gray died in his workshop in Sparks, Nevada, in April 1989, under mysterious circumstances. He was 64 years old and in good health.
Before we get out of here, I just want to let you guys know that I offer memberships on my channel now. Wow. Okay, that wasn't what I was trying to show. Let me pull up part 2. What do you think so far, Joe?
I think it's pretty interesting as far as, like, you know, his discovery of it and what he did with it and everything. At the same time, like, you know, I think that we've come to that better understanding at this point already to a certain degree. And, you know, the lab experiments and everything that everyone's doing is kind of already surpassed, you know, what's being explained in the article. I think that that's sort of where my mind's at.
Well, yeah. I mean, I guess you got to see it in the lab. You can't be a patent jockey when it comes to this. You got to build the experiment to see it. I mean, once you see what he's dealing with, then you can understand the multiplication and everything else. It starts to really make sense. It's like you get in there and you start seeing this energy that has no magnetism to it, but it's expanding out everywhere. You know what I mean? And it doesn't want to be contained. And then
Yeah, I
you
mean,
say
I have to be honest, I've
contained
never
it?
heard his story before, so, it's kind of all news to me. I guess when I was listening to it, the first thing that came to mind when he started with the whole patent and then looking for funding thing, I was like, yeah, he could probably find, funding, in the form of like 9mm in the back of his head with like a
Oh yeah,
suicide note or something,
definitely coming right after him. That's for sure.
I was like, oh man, how many of these people make the same damn mistakes time and time and time and time again,
Oh yeah, well, as soon as they seized everything from your workshop, they already had your stuff. They didn't need to respond to you.
And the way that it was worded made him sound like he was like in some like ignorant bliss. He's like, oh, I'm gonna get it back, right?
Yeah, no, you're done.
Man, it's like you got to take a good look around you. You're not the first one that found something that shouldn't have been found, and you're not seeing the writing on the wall. Like, read the room, man. You're not getting it back. Like, you're lucky that you walk away with it.
Yeah, one of the cool things was he said that it was going back to the battery, right? So we only know that in a bit. So when you create that, it's basically like a horseshoe or something. You put magnets in it, so it basically you're looking at what is a mini of a meg, and you're putting it in there. And then we always say 22 on one side, 11 and 11, and then part of that 11 goes right back to the battery. So you're immediately, completing that circuit and recharging the battery. Then the other side only gets used when he wants it to be used.
Right.
So it was like, wow, okay, well, Tesla did that too. He called it a ringer. So when he used his dynamo, he used a ringer in there to do the same thing.
For sure. I think the one thing I pulled out of it that, like, out of all of our discussions on cold energy and just all the physics around it and everything, I like the way that they described, the idea that when you run a normal hot circuit, it has a certain draw, right? And that's what they consider to be your used electricity. But the fact is that it's really only, the losses from the energy draw are only very little. The losses themselves, which, I think that the way that they put it hit harder than any way we've ever really said it. And imagine again, like if it were a gasoline engine, if the carburetor's taking in all sorts of fuel, and it's cycling, but then the exhaust is just spewing out all this extra gas. Of course, you would want to collect it and put it back into the tank, wouldn't you? Right? Like, doesn't that?
Yeah.
Right? That would be just common sense. Like, you would never let that slide if that was the inefficiency in your mechanical system, right? Yet it's not really thought of that way.
Yeah, it's basically you put in hot energy and then your coil gets hot, and it gets really hot. There's no getting around that, man. That coil gets hot, so I could put it in a rodent coil. It's steaming hot, man. And all that is loss. That whole complete thing is immediately goes right in there first. It's complete loss. There's no getting around it. But when you go cold, your whole coil saturates and there's zero loss in your coil. It's now able to oscillate and produce more energy from it. So, yeah, that's what the cool thing was. And if you understood that based on the testing you do, or you see what I do and see how it's working, man, it just kind of teaches you right there. Hello, we got more energy coming in and we can play with it because hysteresis is not taking place. So,
yeah.
Looking for something, Joe?
Yeah, no, I was just reading the chat. I made a couple of critical errors in my rushing on today the last minute. One of them was I put the light in my room too bright, so like I'm being blinded from the front. Just honesty here. And I really can't dim it while I'm on, so I'm just dealing. Yeah.
Yeah. Oh man. Yeah. It's great, man. I love this kind of stuff because it kind of cuts through the BS of everybody going, oh, well, this doesn't work, or that's not an invention, or this really sucks that you can't do that. And the master himself, Tesla, didn't tell you that you could do this, so you can't do it. So you got handcuffs on you. And these other people are like, well, I don't think so. I'm just going to do it because it works. And then once I find it, who cares? It works. You know what I mean?
Yeah, that old saying, there's more than one way to skin a cat, right?
Yes.
It's just sort of it. And we know that, though. Everything works all the same. You know, you could get the same result in different fashions many, many times over. It's because it all works off of the same general principles. That's kind of what it comes down to.
Oh, yeah. Well, I'll be honest with you, man. I looked up a couple Tesla patents this week, Joe. I had somebody criticize me, and I just couldn't help myself. So I looked up every patent there was, and then looked up everything in the Colorado experiment that was explained to me. Found that there was no page for certain things. But I'll be honest with you, man. I don't think Tesla would disagree with anything here. He was right on it before everyone else. He just never got there. He just never got to this level of it. He himself called his Tesla coil radiant energy. He didn't call it AC or DC, or he didn't call it static, because there is no static from a Tesla coil. Like, let me put it this way. You put static on anything, I dare you to take it to your laminate table and just attach the wire to it. And then go put all your favorite electronics on it. Okay? All of them. And then within 5 minutes, all of them will completely be destroyed. But if you take this energy and tape it to the table, nothing's going to happen. It might turn them on. It might turn on your radio. You know what I mean? It might do a lot of that. But there's zero static in it. So
yeah, I mean, Tesla did kind of do it all, you know. And one thing I love about him, because I could personally relate to it, but at the same exact time, I think was the biggest hindrance to him generally was, he was very scattered and all over the place. Like he had a lot of stuff that he was doing all at one time, and these major multiple commitments that he had, all around him at any given time, really kind of became prohibitive of him, seeing things through to their greatest degree. It's not that he didn't see them through at all, but just maybe didn't see them through to their greatest potential, because he had such a vast expanse to his train of thought as to how it all worked. And I think that it was just as important for him to get as much down as he could in his lifetime as it was for him to accomplish most of these feats, to their highest and most usable forms. I mean, unfortunately, that kind of makes reading some of his works a little difficult, because he could stay on topic when talking about one single invention of his or one single concept, but at the same time, when you look at it in the scope of everything else that was going on at the time, it just bounces around so much that you see the influence of his writings develop from the beginning to the end, where there sometimes even becomes like a little bit of a change in the thought process slightly, as the development of what he's describing kind of comes into clear view for him. I don't know. That's just my take on it, I guess. But
okay, check it out. I was reading Tesla's radiant energy patent, and to be quite honest with you, man, the first thing that popped in my head was solar panel. So basically, he puts that piece of metal, piece of aluminum up in the air, right? And it pulls in the energy from there, brings it down. He uses the negative from the earth, and he pulls the negative into the cell, right? So kind of like what Sean was doing with his Tesla coil, using it as a pump, and you saw the negative pull into it instead of the opposite way around.
Right, the same as Brandon's doing with his
with
white
TV
trailer, and TV panel.
Dude, that TV still spooks me out. But
I live in an antenna. I live in an antenna in Canada.
like a big toaster.
That's it. Crazy ass Canadians.
Oh, but no, it was funny because that's what it came out to be. But then you see the potential of it, right? How do you use that kind of energy? And it was the first conversion of it is what he was doing. That's what was so interesting about it.
Yeah, right.
So,
I mean, the principle of it all is that you need a draw, right? So when we had talked in the past about high efficiency energy systems and being able to actually pull from the ether, so to speak, it was all about that load that was on there. You had to have that draw in order to hold it, right? And it's the same thing with radiant energy too. You need to draw from the ground of the negative energy to be able to draw, to draw on the current.
Yeah. Well, it's kind of the way it works, huh? You gotta get the current from the ground. It's not coming from the air.
When they throw a lightning bolt down, right?
Oh man, I love patent jockeys. They don't know anything about electricity. They know about words. Oh, it cracked me up.
Now, that depends on who you're talking about, I guess.
Yeah, I'm not talking about you, Joe. You're not a patent jockey.
I don't have shit. I don't have a patent. I don't have an invention. I don't have a project. I don't have an idea. I don't know what I'm talking about. All the good stuff. You know what I mean? Like, I just roll with it, bro. You know this.
Oh, dude, that's what's so awesome about you. No, I look into everything when you criticize me and you sit there, or anybody does, and they give me their whole spiel on where it is. I just wish it was more direct because they're pulling the wrong patents. If you want to argue with me, you better argue with the right one. You know what I mean?
Yeah, it's fair. There's such thing as constructive criticism and so on. I think that the key here is that, it's not hurting anyone, and everyone well knows that you do at your own risk and ability.
I just think it's funny. No, because I get criticized for, you could be running 1,000,000 volts to a DC flyback with 12 volts of input. And they're an electrical engineer. And I'm going, really? Well, did you go back to school and learn the math? Because you obviously did not learn it then and did not learn what you were doing. You maybe get, 20,000 volts if you're lucky. And at that, there is no current in it hardly. So you're going to get a big, giant static shock, and you're not going to get, let me throw you across the room like 220 does. You know what I mean?
Oh, yeah. I know about that.
I find it hilarious, and like somebody goes, "Oh well, let me quote this." Well, let's quote it. Let's read it. You know what? I went as far as saying, you know what, buddy? Let's go ahead and do the AI thing, and we'll just pull a voice into it. You know what I mean?
Yeah.
And just let them say it. And I did both of them, and I'm like, all right, because I already did, one of them. So let's find out. I'll be honest with you, man. I just don't see the point in it. And I'll just make my final point on this and I'll let it go. We're here to learn. We're here to find out what things do. We're not here to circle jerk a patent. That's not what we're here for. We're all here to learn and teach each other stuff. And people come on, man, and I'll be honest with you, I shut my mouth and let them say what their piece and get it out. You know what I mean? Because that's what they believe, and that's cool. You know what I mean? I'm not there to discourage anyone. But you send me a message discouraging me, man. You can, what I mean? Take your little bag and go home.
This is why I play it safe and don't literally say that I don't know shit, because every so often I'll come out with a gem and everything that I say is wrong. Just assume it was wrong to begin with. That's perfectly fine.
Well, like a diamond's in a goat's ass. You just got it.
Yeah.
Oh my God. Yeah, man. Look,
it's all good, man. It's all peace and love. We just like to keep it that way, man.
It's all good, brother. Now I'm over it, man. I'll let the masters speak on it when I do the thing, man. But this is cool though. I really did like this, man, with the cold current and stuff, because he's starting to figure it out. It's like most people don't get to that stage. They go, "Oh, well, I looked at it." and the circuit looked wrong, so I looked at it. Like, when you say you looked at it, which means I spent all of 1 minute and then decided to move on and got nothing out of it. Like, people tell me all the time, oh, I looked at it. But dude, you might as well tell me you wiped with the left hand instead of the right, because it doesn't mean anything when you say it. You know what I mean?
Yeah.
If you put some time into it and said, okay, well, I built a circuit and then it didn't work, well, then I'd have more respect for you. You know what I mean? If you said, okay, I tried to run it in the negative form, didn't work. Okay. Or, hey, I found an anomaly here that doesn't make any sense when I run this thing because it has 0 resistors in it. Okay. I mean, at least you have something you learned from it, but I looked at it. It just has one of those like Aunt Alice type of things. I looked at it. Every time I hear that, it's like pokes in the eyes and the ears. You know what I mean? It's like, oh, like you're kidding me, right? God, I looked at it. Oh, I hate those things, man. I truly do.
Sounds pretty fucking gay, bro.
Yeah. Well, I don't know that.
Whatever it is. Just real quick, while we're on a little side drift here.
Oh,
everybody knows Sean is usually on Wednesdays.
Oh yeah.
I just want to let everybody know Sean's doing all right. He's just kind of trying to catch up. And kind of get his energy back in him from after a procedure that went well and everything. So, God willing and everything, he'll be back next week. But I know that, what he had going on, was on Monday. So I don't think that he really did all that much experimentation between, what he provided from last week till now. So, we're working with what we got here. All right. Like, I know it's no fun plasma on Wednesdays this time around. Like,
no, it's all good, man.
Yeah.
Yeah. Sean said he'd be back. He's excited, man. Dude, this is his favorite thing to do is present. That's why I just let him go do whatever he wants.
He's one of my favorite people on earth, man. They don't get better than that.
Yeah. Sean's awesome, brother. So yeah, Sean, we hope you get better soon, man, and get back here next week. And, if you ever want to pop on, if you feel any better on one of our streams, by all means, pop on and say hi. So, yeah.
Yeah, I just thought that was important to mention and everything, because frankly, I miss the guy. He keeps me and the rest, kind of in the loop backstage leading up to it. So kind of usually know what's coming. And, he'd really been on a roll with some of these geometry, Tesla coils and everything and plasma they're putting out. It's just super interesting stuff. So can't wait to get back to that. I'd gladly bow out for these things just to watch him, frankly.
Oh, me too. Yeah, that's why he's usually Wednesday. You know what I mean? I expect him every week, and I'm disappointed when he's not on. I'm like, oh man,
he's disappointed when he's not on. I heard from him today, and he was super bummed. I was like, it's all right, man. Don't worry. We'll make the world go around a little bit. You'll be back.
Yeah, I'll tell you what. For Sean, let me pull up his thing real quick. Let me see what's the last thing he left me on there, because he's got a lot going on there. Oh, here we go. One of my favorite pictures, Joe. I'll just pull this up. Joe sent me a bunch of stuff to watch in physics, and this is what happened.
Yeah, we know. Love me some physics. For real.
Oh, man. Yeah. I'm sorry, man. I kept falling asleep. I was like, all right, you got to hype me up for this. And then like 5 to 10 minutes in, and they started going over numbers, and I'm like, oh.
Oh, my
head. I was like, no, it's not happening. I gotta change this.
That was a suggestion that I had for New Year's Eve. I said that we should all get around our own independent little fire and just sit there and drink some bourbon and BS for our Christmas Eve show. It just seemed like a good thing to do at the time, but I don't know. Next year. Believe it or not, we're almost halfway there.
Yeah, we're getting there.
Crazy, man.
All right, hold on. I'm gonna play. Sean was, I guess there's a better term to say this, but he was out shocking his balls. So,
Yeah.
Oh, all right.
Yeah, Sean got them blue purple balls.
So he's doing some kind of electrostatic test to him, and they're glass beads, and they're moving around and going back and forth. Man, I'm gonna have to look for the other one because this one doesn't look that exciting. Hold on. Let me stop sharing that one, and I'll find the other one because he was really blasting with some electricity too.
Yeah, those glass balls, they act very interesting because they act like structured fluids.
Yeah. Trying to find. Oh, okay. Hold on. Maybe I found it. Yeah, it makes cool patterns in there too, doesn't it?
Yeah, it does. Yeah, it's more diffuse. You know, it's more in this. It's more like plasma, almost in a state of like a pseudo equilibrium. It looks like, rather than how it has all the high and low point patterning going on in the typical discharge.
Dude, I see like the flower of life forming in there. Don't know if you see it, like the little leaves.
So small on my screen. I did see it before, but I need to zoom in. Yeah, that's interesting. You know, it has like one of those, you know, that phenomena that kind of exists in lasers where it kind of gives like that little dance in the beam. You know, it's kind of got like that phenomena going on in it.
Yeah. So he said he was shocking them, right? And the electricity would be in there. And then we saw the later experiment. I guess it would have helped to show that second. That it stayed in there, but overnight it dissipates.
Mm. You know, now that I'm thinking about it, with the glass beads in there, the plasma discharge and them being like, you know, semiconductive is probably, it's probably like some kind of like refraction type of, you know, effect that's going on with the light given off by the plasmatic discharge. That's leading it to look more diffuse than it really is.
Yeah. Well, I agree with the chat in here. Heating it up, and then it gets it to give off an energy, and then they move. Yeah, I could see that all day. It's the same thing as taking a cylinder and rotating it with sand and then charging it. You're going to get that static off of it. So, but it won't do it until you do it on a, what is it, molecular scale, down to the little particles of it. You got to charge those and then trap it. This right here charges them for just a little bit of time. So,
yeah, this is good testing for them because I know that those beads probably are like, you know, some kind of aggregate that he's planning on, you know, utilizing in an electret. So, you know, understanding its you know, its static properties and so on are probably pretty critical to him knowing what to do with it exactly when it comes to that application.
yeah, I'll tell you what, that thing at night looks awesome.
Yeah.
Look at that. Yeah, it's definitely got a pattern in there, Joe. I wish you could see it bigger.
Yeah, no, I definitely see that it's doing something repeating. And all right, let me look closer.
It's a flower.
Okay. So I actually, what I'm seeing is kind of one interesting thing that's repeating over and over again.
Okay.
That's the tendrils that are next to each other. Like you, and I guess that's how you're seeing the flower. I don't see the flower per se, as far as like a sacred geometry sort of thing would be concerned. But what I see is the tendrils actually coming in to, a common point toward each other, which is unusual. That's an unusual circumstance. Now, I don't know if that's because of the containment.
Well,
Potentially.
They come to a point, but they also start at a point. So that's what I mean. That's why I say the flower, like that.
Yeah, I get what you're saying out of it. Sure. Here, I'll tell you what. Pause it. See how you had it paused right there? Pause it at a couple more. So I could just. That one has like almost a ring. Okay, there you got 5 points coming out. Actually, 10 points meeting at 5 on that other one.
Let me see. Yeah, there's some.
Not seeing a lot of repeating going on though.
No, it's only when it's faster.
Yeah, which means that it's repetitive in sequence, but I don't know. These are things that I play with in my own spare time when I'm trying to pick the patterns out of things. Usually I could do it on the fly, but like that's cool. Whatever that last one was, that was almost 3-dimensional. There's another 5 point. So it's interesting stuff. It's just I think when it's in a state of containment, there's also a lot of interference with itself going on. Also, that might break up the standard patterns that I pick up in his work.
Yeah, this one kind of looks like a spider. That just reminds me of a spider. I don't know why.
Yeah, limited state's making a good point. I would like to at least take the time to analyze it a little bit more. I obviously don't have the ability to do the experimentation. I wish I did and get there.
Yeah, I think it looks pretty cool. I like it. Let's see what else he's up to, man. Yeah, but that's what he said. He got all kind of new power sources, man, to do this thing.
Yeah.
So he wanted to show that today. I wish.
Well,
able to.
See, the one thing I wish I could see better in that is the interaction of the glass beads, because I think that's kind of the significance of the experiment itself, less what the plasma is doing. Obviously, if you could pick something up in the plasma, probably be a good indicator of something. But I'm right there again. It's hard to really say what the exact repeating pattern was, but I'd like to know what the glass beads were doing, and they weren't super visible. So.
Well, I would say if you can get that same electrostatic charge on them while they're in hot beeswax, and then let it, get solid all the way around them, I bet he'd hold in the charge a lot longer than what he's getting because there's a containment to it. That right now there's no containment; it just goes out to the air right away.
Well, something that was important that we already saw the last time we showed it, which was last week, I think, was when they were heavy enough, when they were in a heavy enough degree of saturation of static, they were structuring into pentagons. No, not pentagons, hexagons. I think it was 5 points. Yeah, so it was hexagonal. So it was almost like, which is interesting when you think about beeswax as a medium for them, because that structures hexagonally as well. So there should be some type of material resonance characteristics that are present in both that are similar because they structure the same. Obviously one structure is maybe at a different scale than the other, but it would be interesting to see that. I agree entirely.
Okay. I wanted to show you what else Sean was making. He's making me the Death Star Tesla coil, right? So here's the picture he showed me of it. I told him he's got a nice rack.
Looks like Gerald Circuit.
Oh, they must have had a conference, man.
Gotta give it a
Oh man, no, but it's coming out good.
How's your ladies?
Oh man,
Try to squeeze it a smack, make sure it's good.
Oh, I'm excited, man. He's excited for me to get that thing and test it out. To just put it through every pace we can. I want to know if that energy's hot coming out of it, because it avoids things and then doesn't mess with his camera. There's not a bunch of lines on it, and he's directly right over this thing, which has never happened to me in voltage that's sparking. It always affects the camera. So I'm excited to test that, verify what he's doing.
Yeah, I mean that's where it gets loaded. It seems like when it comes to like capturing some of these things, it's camera sensors for obvious reasons are going to be super sensitive to all these different energies. But film isn't really out of that equation either. If you were to go old school, like it's hard to capture it on film too because it becomes exposed. So it's one of these very, very difficult things.
Huh. Yeah, I can see that.
Yeah.
Here is your geometry, Joe. Sorry, I'm looking through it while we're talking.
Yeah, that's it. The baggy geometry.
Perfect distance apart, too.
Yeah.
We were looking at Monday. One of the guys had put in a video, and it was creating what looked like a bolt of energy going from the ground up. And he said that there was a UAP or something over top, and then it was crystal putting it off, and it had a repeating pattern to it. And this thing, Joe, it was literally timing. You could hear the timing of it and stop it and find the discharge every time. As soon as you learn the pattern, which means it was in the very low hertz. So it was kind of like a clue. If he's right, and he said it's crystal doing it, if it's crystal doing it, man, we may be looking at very low hertz to turn one of these things on.
Was the predictability like kind of similar to the sound of like a charging capacitor where it raises in frequency until it hits?
Yes.
Yep. Well, that makes sense, doesn't it?
Yeah, give me 1 second, Joe. We'll talk real quick while I look this up. I'll see if I can't find it. Yeah, it was pretty cool, man, the way it went off. So, like he said it was a UFO experience. He turned it into the people who look into the UFO thing. And then he also put in something with the government on it.
Nice.
Okay.
You might find some answers through being suppressed through threatening.
Well, yeah. Okay, so here we go.
Yeah. What was it? Arrow? They don't exactly have the best track record.
That sound familiar?
Yeah. You played that the other day. What? Who sent that? Was it Dead Fish?
Yeah.
Yeah.
Oh, I keep missing it. All right.
Yeah, no, it's definitely repeating, and
Which, if he's right, it's in the low hertz.
yeah, well, I mean, the good thing about capturing these sorts of things is that they're really open to analysis. Like, you could manipulate the audio, you could and analyze the audio, you can manipulate the the exposures and stuff like that through different filters and whatnot to pick out different things that you might not be able to see otherwise. So, it's important to capture everything that you can and then figure the best way to analyze it. Yeah, and think that that's kind of what it boils down to. Like something like that, seeing that the audio is a cue to the discharge, it's equally as important to analyze the audio signature, and then as it is in conjunction with what you're seeing happening. If you actually bring it right into like just a video editor or something like that, usually you can separate and analyze the audio right on top of the video as it's happening, and then actually see the different levels raising up, what frequency it's at, like audio frequency wise, right? And actually see what's occurring visually at that same time. So it's kind of an important thing to do in something like a video like that.
Okay, Joe, let's check this out. I'm going to pull up a video here. And I just want to see in the video if it'll pull it up. I put these two Tesla coils. Oop, okay, sorry. So, real quick, the only thing I want to show in this is there's two Tesla coils on top of each other. Each one resonates around 250, right? 250, 260. So, by combining them, see if I can find the spot right there. We get down to 165. Now, the 32 gauge magnet wire on 12 inches of winding each. So on a 4-inch pipe, now we have a 4-inch pipe with 24 inches, so 2 feet of winding, and we got down to 165. In order to put something in resonance at low hertz level, I figure it's taking off 100 kilohertz each time I add one, right?
So it's not like it's proportional. It's not like orders of magnitude every time you.
It's proportional.
Usually, I feel like it would be like a diminishing return.
It'd be less each time, is what you're saying. After I hit it on the third one.
I think so.
Okay.
Yeah, I think that's going to suffer from diminishing return, but that doesn't mean you can't get there.
Well, I'm trying to figure out. So I have 5 of them, and I can test the theory, right? And you might be right about diminishing return because the primary is only so big. You know what I mean? So what I'm looking at is how many would it take all 5 then, if you kind of put it in that level to get down to the hertz level? Or do I probably have to build a wider pipe from the beginning so it doesn't diminish?
Yeah, I mean, it becomes another one of these math equations with once you add the diminishing return idea into it, because now you would need to adjust your input levels to be greater to try and fight against the diminishing return, so to speak, which then would require more, tubes, so to speak, to a bigger length to be able to get it to the point that you want. So it's sort of like you would need to work it out. Like what the sweet spot is of that between your input and your length to achieve the specific frequency that you're trying to achieve would, again, it would be like a pretty complex math equation, I think, but not an unachievable one. If you have the information on what the diminishing return is and how that is affected by your input.
Well, it'd still be scalable if you get into the multitude of 4 of them. You'd still
Absolutely, it's
find out the
scalable,
scale.
definitely. Yeah, everything's scalable. It's just a matter of what needs to be tweaked to get the outcome you're looking for, right?
Yeah, well,
But more than one factor is what I'm saying.
Okay, so I was just wondering if, how do I want to say this? If I drop 4 on there, could I be in the hertz? And it could be in the high hertz or anything else. I just want to see so that I'm dealing with 4-inch pipe now. If I pull to an 8-inch pipe, how long does it have to be, you know what I mean, to get me into the low hertz? So that's kind of what I'm looking at. I'm thinking it's somewhere, if it scales out, then somewhere in 3 feet at an 8-inch wide pipe. And I should be somewhere in the hertz.
But I not to, this is just a little bit of an assumption here, but if you're going off of diminishing return, right, input and everything, like, does that explain why Wardenclyffe was the size that it was? You get what I'm saying? Because you need the higher input, and then with that you need the higher, a longer situation.
I don't think
so.
Wardenclyffe isn't what you think it is. It's not a transmission tower.
It's not a transmission tower. I know that. It's a radiant energy tower from Earth energy.
No, but it's worse than that. As soon as he stuck the wood down the center of the Tesla coil, he changed that whole thing. People don't realize what he did. And it goes to his cold electricity circuit that he did. Or not cold electricity, his radiant energy circuit. And let me just explain it like this. When he stuck that wood down it, he reduced the amount of voltage that was in it. He was actually reducing the voltage that was coming in from the sky and reducing it down in order to have enough draw for the amperage to pull out of the ground. So I could tell you that based on just go take an open core transformer and put a core in it. Find out what happens. It's going to change your whole thing because it's going to drop the frequency.
Well, right, your fields start to compress at that point.
Yes, exactly. So he was doing that in Wardenclyffe. So it was definitely a pull-in from the sky. It couldn't be a radiating out field. And you would only know that if you took a Tesla coil and did the experiment, because it won't work the other way. It won't work as a transmitter that way. It was never designed to be one. It would be a very poor transmitter. Let me put it that way. The way he designed that thing with a variable capacitor to the earth. No. Totally different purpose going on there. But that's neither here nor there today. I'm just trying to figure out how to get this thing down because I want to build this thing once, maybe twice, but I want to be in the ballpark the first time. So I can always go higher. I want to go lower, which means it's kind of like a big investment to hit it the first time. You know what I mean? So it's $120 for the wire for a whole 5-pound spool of it. It's close to what it's going to take. The 8-inch pipe is another $100. So I'm going to be out $300 in one experiment to find out if I can hit the low hertz. So I kind of want to get it right. You know what I mean?
Yeah, for sure. I would definitely just, as a baseline, I would just use what you have on hand to get an idea of what the effect is, if you can.
Well, I think
if that just means stacking, if that's something you could do. I mean, frankly, between me and you, I'm not familiar enough with exactly how everything you do is set up to know whether or not that would work. But if you can,
I look, I could set it on the ground and do it. I don't think that's a problem. And doing the test would be easy. I need to limit the diminish because of the height. You know what I mean? Because I think it's going to give an inaccurate reading. Which, if it pulls me lower, the lower is fine. You know what I mean? Because I have to keep adding more mass to it to get it to go lower. So if I want it to go higher, it's pretty easy.
Okay, then doesn't that come down to the proportions of it just generally? So, you know, if you mess with the geometry of it a little bit and, you know, you make it wider, you know, maybe that could kind of help bridge the gap a little bit.
Well, yeah, it'll be double the mass. I mean, I could just do the math equation for that. That's not a problem. You just, you know what I mean? Find out the diameter of it. Yeah, I don't think that's what's getting me, because Tesla built things that are huge. I mean, you know, 12 inches round, it wouldn't be a problem for him. And then he only had to go up so high. So his primary didn't have to be super huge, right? So the diminishing, it goes away. The wider you get, the easier it is, but the less height you have to have. That's what I'm getting at here. There's a whole dimensionality to the problem. And I kind of want it to look still like a Tesla coil, right? But I don't think I want it over 4 feet. So maybe I should just go 4 feet and pull some back when I get there, because what I'm trying to do, Joe, is I want to get it down to the tuning fork level.
Yeah.
And want to start ringing the tuning forks with it. So I need something that hits that. Now I can do it with the regular transformer, but I'd much rather do it, you know what I mean, with the Tesla coil and show people that it can work.
Yeah, I mean, it's probably attainable. Just like, you know, go slow with it and just check to see what the diminishing loss is before you full blown commit to your $300 investment. That's all.
Well, yeah. I mean,
isn't kind of the beauty of your winder machine that you could also rewind it onto something else. Like,
oh, you could. No, you could.
So,
yeah, it's not what I try to do, man. I have most of the spool of a 32 right now. It's only had 5 Tesla coils pulled off of it, so it's mostly there. I think I can find the pipe used, but it can't have any bends in it. As soon as they get outside, they get all warpy and bendy. I need to find a guy that, you know what I mean, just does this for a living and has a bunch of it sitting over like scrap parts that, you know what I mean, in his shop. I gotta, you know, just find somebody who does it.
Any update on Gravwell, or is that just a headache at this point?
No, dude, it's all in one piece now. I should probably show you a picture. It's all together, and it rotates just fine. To be honest with you, man, I kind of put it to the side. So I got it up and running, and I probably should have just shown that before I did that. Not ready to go to that next step yet.
It's reasonable. I get it.
Yeah. I was kind of trying to figure something else out, man. I've been mapping my rodent coil here lately.
Yeah, I know you've been showing me. That's cool.
So I'm finding all of the frequencies in it and the amplification in it. And I don't know, man. I'm trying to get it to overunity and to put a bypass switch on it. And I'm not sure exactly how I want to do it. And every switch that I use, man, it turns off here real quick. I should probably just use diodes and stop it from going back to certain places. That might be a better avenue. But I'm just having headache after headache with it. So I blew a bunch of parts out of it this last week. They just came in yesterday. So, yeah, like, I don't know, like $150 worth of parts just in the trash.
Yeah, man.
Just in one day. So
isn't that the way it goes sometimes? That's like, subscribe, don't forget to join.
Yeah.
You know?
All those things help me out.
Yeah, don't forget that old man has a Patreon in case you want to assist with some of this experimentation. Maybe we could get the videos out a little sooner with the full analysis.
I mean, look, man, my experiments are kind of simple, and I understand that, and I agree with most people when they say that. All right, I'm not hurting on that. It's trying to get to proofs of points. You know what I mean? Each one, and
yeah, you took the words out of my mouth, man. Like the proof of concept,
yeah,
is just as important as anything else. Real quick, before we lose the comment altogether, just because it seemed interesting, I saw it pop up in the chat, but it looks like a spirit rabbit over there.
What's he got going on?
Something to the effect of he has a circuit that takes human electric field. So human capacitance circuit, says it feeds back to the human. Might be interesting, cool. Man. You should come on and share that, you know?
Oh, absolutely. Come on and share that. We all want to know that one. Yeah, absolutely.
Yeah, sorry, I didn't want to lose that comment. It was...
No, that'd be cool, man. So I think when we start getting to that low hertz, it's going to start messing with a lot of things, Joe.
Yeah, I mean, that's kind of been the experience that I think most people have had getting into those, you know, near Schumann's resonance. And, you know, once you start getting like into that 10 hertz range too, like really low. Really low. Really low.
Oh, I get it.
Yeah.
Yeah. You know what? That's the only way to do it, though. We got to prove out, even if it's just a verification thing where you're just building something somebody else does, man. That's it. So, yeah, I look back on some of the things that I did, man, and see if I built it right. And some of the things I dead on. You know what I mean? Putting something in resonance, not a problem. I can figure that out. You know what I mean? I was doing 2 Tesla coils this week for Charlie C. He wanted a 1 megahertz Tesla coil. That's the green coil I showed. Yeah, got them both. So I built one that's 1 megahertz, and it's just, you know, running on a Slayer exciter. And then I built another one that if you put something down in it, it'll go back to 1 megahertz. So it's, oh God, it was over by 124 kilohertz. And as soon as you put the wire down in it, it hit 1.05 hertz, or kilohertz, or megahertz. I'm sorry, megahertz. I keep wanting to say. So he's got a 1 megahertz coil, one that's 1 megahertz as soon as he puts a, you know, something in the center of it. And both on Slayer exciters. I built the positive Slayer exciter, so an NPN. And then I built a PNP Slayer exciter to go with it as well. And then extra parts. So both of those things, man, are ready to go ship out tomorrow. So
yeah. Hey, well, speaking of like low frequencies, Sabine came out with a video on consciousness.
It wasn't that pipe, was it? Was it something else?
It was on consciousness, the one that I'm talking about. And it was just saying like that what scientists have recently found is that the mind works continuously on the verge of like total disorder and chaos. So that basically the reason our like and our like neural synapses like work relatively slow through our neurological system, right? So they're trying to figure out how you can make these lightning fast thoughts, decisions, so on and so forth, right?
Mm-hmm.
You know, in such a slow moving system. And they likened it to quantum mechanics and which I'll actually liken it to more the ether, okay? Which is like a push and pull effect, right? So you have like this orderly system that runs on the verge of chaos. As soon as disorder comes into play, it immediately has a reaction through the whole system. So it's like the pickup truck with the chain attached to the back, you know, a mile away, right? So it drives an inch, and a mile away you move an inch.
Yeah.
Same exact thing. it's that response system. Same thing as the ether, same thing as quantum mechanics, and now they're saying that about how, the workings of your neurological system. Now, I personally separate consciousness from your neurological workings. That's my preference to do that. But obviously there's some kind of connection because there's a readable signal that obviously goes through that has to do with your consciousness and your behaviors. It's your remote controlled hands,
I saw that title and I didn't know if she was going to talk about that little pipe for free energy. And I didn't click on it because I didn't want to hear about it. So if you tell me,
she didn't go there today.
Okay, I'll watch that one.
I'm sure she will.
Yeah, that's the one physicist I can listen to that's not boring. It's something going on. You know what I mean? So some of the other ones, man, I'm just like, oh my God. Oh, and by the way, real quick, if you guys wanted to see that Peter Lindemann thing, it's on my podcast channel. Here's the in the chat. I put up the podcast channel here. Pop over there. There's 4 parts to it. They're all put together on one thing, so you can just listen in your car on YouTube Music and just hit the podcast and listen to all of it. The whole thing's fascinating, by the way. All right.
Real quick, 8th, my crystal dig is on Saturday.
Oh,
so
very cool.
There's that. Yeah, so I'll be getting together with Old Man and see if he wants to stream a little bit of my endeavor, see how that looks.
Oh,
it's
yeah.
Not too rainy. And somebody else said Yi Sabine. Well, yeah, Yi Sabine. I don't really agree with some of the things that she says or where she's come from. But here's where I like hammer down with Sabine, right? Is that physicists have hated her for a long time, and more physicists hate her day in and day out. Okay. And what you'll notice if you've been following her long enough is the more the scientific community hates her, the more she leans into all the stuff we talk about.
Oh, and the more she's right, by the way.
Yeah. And she'll give you nods on the nuggets if you listen. She doesn't outright say it all the time, but she gives you nods on the nuggets.
Yeah. No, that was cool, man. And then I sent you that frequency one with the all the speakers that go around that big halo.
Yep.
And they were influencing the plasma coming out of a Tesla coil. So I sent that to Sean. He really liked that one. There was a while back on Alien Scientist channel, he had a guy on who did the same thing. And he just had one of those ones that are rounded on both sides. Setting up like this, and you put it in there, and it would bend it and change it between each frequency that you put in. So, but then again, think about that when we discussed Sean's plasma and we looked at the tendrils, right? And then John came on and told us to look at every single one of them, right? Because there's multiple layers of each one. Now it starts to make sense because if they're built out in frequency and they're changing the frequency, it changes in between each one you go to.
Nice. Yep. By the way, yep. High Science has got what I was saying when I repeat it over and over again that she nods on my nugs. Thank you. It was a bad
kind
joke.
of avoided that one.
Me out.
Oh, wow.
She ain't my type. She's that cold German kind.
Einstein. Oh, man. No, I do like it when she came out with the scientists created their own little bubble. You know what I mean? And they get paid that way. Oh, that was one of the best right there. It was like, yeah, no wonder why they didn't get this when it was all out there.
Now, I like consume so much material from time to time that I get a little discombobulated in exactly what it was. But you shared with me an Action Labs one that came out like either today or yesterday or whatever too, and that one was good.
That was the frequency in.
That was the frequency one. Oh,
yeah,
okay.
Yeah, that guy's really good, man.
Yeah,
I think everybody sent me that one too. They're like, hey, did you see this? Did you see this? Yeah. Yeah, I saw it all right, man.
Yeah, well, and that's working in like the ultrasound range, you know. That's like high frequency, very high. Yeah, but yeah, that's how it works. You got to remember, sound scalar, you know. So
Well, that's what I was trying to say with the tendrils with Sean. It's the same thing. You know what I mean? We're going to be working in frequency and playing with it. I wish more people would get into doing that, man. That just seemed cool. So
yeah,
might be
I
worth
wish some
building
of
one
the
of those.
equipment to play with all that high frequency stuff wasn't so expensive.
Yeah, if they had an affordable kit.
Well, I think that the cheapest. It's kind of funny that I'm saying this, but it happens to be true. I think the cheapest way into ultrasonics is they have these cavitation machines. You know, they're meant for you to burn away, like, you know, your belly fat and stuff. Which, by the way, I'm going to tell you something. They work.
Really?
They work. Yeah, I used to have one. They work. All right. But
So you just
you know,
went
like,
over there and rubbed your belly like this, and then.
all right. So actually, it's funny because it works off of all the same principles we like to discuss regularly on this channel, right? So these fat cavitation machines, what they do is they have 3 modes. Okay, they have an ultrasound mode where you could set the frequency, and it's like pretty high frequency. It's like 40K. Okay, so you set the frequency, and it runs the frequency through a transducer probe. Okay, with an RF light. Okay, so what it's doing is it's heating all your stuff up under the surface with the RF light, and then breaking it apart, cavitating it with the frequency. All the frequencies that you could choose are basically in tune with with breaking apart the fat. That's how it works. Okay. Then once you break the fat loose of its mass, then you basically use a vacuum to suck it to your lymph system, and then you get rid of it, and it works. It's real
So
deal.
first it vibrates you, then it sucks you.
No, it doesn't vibrate. It actually kind of like the ultrasound, kind of like. I mean, listen. If that's what you're into, man, more power to you. But that sounds like more like a BDSM thing than it does like anything else. Because yeah, I mean this thing's throwing the goods out that probe, man. Like the frequency that it's throwing out, it's cavitating below your skin. So
Okay.
and it feels like a shock, which now mind you something, it feels like a shock, except there's no electricity, so to speak, discharge.
Okay? It sounds like a bunch of static shocks. Yeah.
Well, it sounds like static shock, but it's actually just ultrasound. That's all it is. It's just a sonic wave.
Okay.
But a sonic wave isn't any different than electromagnetism. That's the thing, So, whatever. Spend $700 on one to like the cheapest one you're going to get that's like really good is $700. They go up to like $2,000. The more you spend, the better it generally is. Although they sell the same models within like a $500 price range, so you gotta kind of use your brain. But I think one of those machines, getting back to the point, I think one of those machines or 2 of those machines, like is the cheapest way into like using good ultrasound, because it gives you everything you need. It gives you all the circuitry is already set up. It's all digital circuitry that allows you to control the frequency output. The transducers work really nice. It's all there for you.
It's a lot of money, man. $700 to reduce your fat.
Well, that's kind of cheap when you think about it.
I mean, I guess. Does it come back the same way? Better than eating healthy, huh?
That's what I'm saying. It's cheaper than eating healthy. I'm not saying better. Eating healthy is actually good.
Yeah.
Yeah.
Part I have a problem with is not the food part, it's the drinks, man. You got water all the time. It's so boring. You know what I mean?
I know. Preaching to the choir, bro. I live off of Monster Energy, and I used to drink a lot of Seltzer, but
That gets
That was my
control.
thing. Yeah.
Those monsters, man, they just skyrocketed my blood pressure. I had to stop.
Yeah, they probably do the same to me, but like, you know, something's got to keep me awake.
Well, maybe I should watch those when I watch the physics videos, huh? Maybe then I'll stay awake.
Yeah. Well, you know, it just is what it is. I've been cycling around what I listen to while I'm working and whatnot because, like, you know, I gotta have like something in the background, at least something that I'm not super interested in, that it's distracting me, but like it can't be annoying either. And I used to watch physics videos all the time, but like I'd either be super interested in it or be so bored that I'm sitting there nodding off. So I was like, enough of this. This is bad subject matter. So now I just put on all these true crime things with like the body cams and stuff, and I'm like, yo, this is a win-win because I get to find out how like depraved people generally are. You know, not generally are, but can be. You know, and like how my problems aren't so bad. It's like, and yeah, man, the stuff these people do, it's absolutely out of control. So that's what I've been into lately while I'm working.
Okay, Joe, check this out. I was just Society of High Sciences sent me a video. So
all right, let's crank her up.
Yeah, let me make sure I get the right one here. Yeah, I got the right one.
Will demonstrate a simplistic devoid bulb of any metal electrodes. It possesses a mixture of mercury vapor as well as caustic potash vapor, so that the objective is to obtain a similar effect to what Nikola Tesla would have most likely experienced, given that he used a Sprengel mercury drop pump. Now, this bulb measures about 3 inches in diameter, and it is placed in between two inward-facing coils operated in cosmic induction mode generator setup. And these coils are conical coils, so that to experimentally see how these coils behave as opposed to the traditional elongated coil. Now, the two metallic spheres are the two experimental capacitive loading ends, which will inadvertently distribute the dielectric lines of force evenly around the bulb and around the material around the bulb. So now I will increase the power and go to the transmitter supplying these coils. Okay, we have now keyed up the transmitter. It is running right now at only 4 watts. We can see that there is a faint glow in the bulb. That's the residual mercury vapor, as well as any remaining water molecules and oxygen molecules trapped within the bulb. I have tuned it up for this purpose just to see where the setup is going to land in terms of frequency. And right now we're operating at around 5.436 megacycles. And again, I want to say that we're only delivering 4 watts into the system, in which the set of coils exhibit a magnification factor of 800, and that the 4 watts going into the system are being effectively magnified by 800 tons. Now I will turn the lights off, and we will then slowly begin to increase the power to see the effects observed. Okay, the lights have been turned off.
Oh, so much better.
I must say that the color being depicted by the camera right now is more of a turquoise color, when in fact the actual color is more of a whitish, very light purple, quintessential mercury vapor. Now I will start to slowly increase the power, mining the SWR of the transmitter and tuner, and also the frequency is most likely going to be dragged down as the plasma inside the bulb eventually warms up. So now it is at 4 watts. Now I will start to slowly increase the power. Okay, 22 watts. I will adjust the SWR. I am lowering the frequency. And in the background, I'm adjusting the antenna inductor of the tuning unit so that the SWR is effectively minimized. Okay, it became a little brighter. Now we will step up the power to 40 watts right now. Let me increase and adjust the frequency and inductor. Okay, now we're at 5.41 megacycles. And I have adjusted the inductor. Let's bring it up in power. 66 watts, lowering the frequency. Once more. And we're at 5.39 megacycles. I will increase the power once more. 82 watts, lower the frequency. Okay, now
I want to
we're
throw
at
out there, this is not a safe
5.38
experiment
megacycles.
Why?
That's the inductor.
because of the ultraviolet
And now we
spectrum
are
that's
at
being
100
drawn off of it.
watts.
Mm.
And our frequency has to be lowered again to 5.3 megacycles. Okay, now the formation is starting to take place. A separation is occurring,
Yep.
which
Cool.
is of a pinkish hue. It has transformed color. And now in the space of cancellation, there will emit a mercury line, so to speak. So let's give it time. We see that there's an effect occurring near the base of the bulb. And
That's
eventually this mercury will
Yeah,
become
but,
excited to expand towards the top end.
Oh,
of
look
the
at that.
Yeah.
And now the mercury line has formed. See, by adjusting the frequency effectively, we are now at 5.37 megacycles. And the line will start to vibrate now as it becomes heavily excited.
Someone
See
call
that there are
Ashton.
multiple lines, about 4.
That might well be internal charge
And if I
separation
continue
right
to
at
adjust the
play,
piston,
just not in motion.
Yeah.
that to maximize efficiency. You find that around there is the most optimum spot. And we have 3 sets of lines appearing. Now, of course, this seems to be dependent upon the placement of the bulb between the null zone. So now I will shut the power off and relocate the bulb slightly more towards the left so that it is in line with the cancellation zone, because right now it seems to be slightly off balance. Okay, we reposition the bulb so that it is slightly leftwards, but also slightly by about a centimeter taken out towards the camera out of the direction of the coil. So right now, for tuning purposes, we're set at 8 watts. The frequency is higher now because the actual ions inside the bulb haven't reached their excitation level. We are sitting at around 4.5, sorry, that is 5.49 megacycles, roughly 5.5. And I will now increase the power and we will observe the frequency decrement. Okay, we're at 26 watts. Let's retune the system. We are decreasing the frequency. Right now we're at around 5.39. We are adjusting the tuning condensers. And we have reached optimum capacity right there. So now we will increase the power once again. We are at 38 watts. And we will adjust the frequency again, 5.38 megacycles. And we will increase the power, 56 watts. Decrease our frequency. And there, 5.37. We see that the lines are already apparent because the bulb has been warmed up. We adjust our inductor, low SWR, increase the power again, 70 watts. And let's see, the bulb went dark. Okay, there we go. 5.36 megacycles. Increase our power from 70 to 85. Lower our frequency to about 5.359. Increase to full power, 100 watts. Just our frequency. And we are sitting at 5.356 megacycles. And our SWR is 1:1 now. So we are sitting at maximum power efficiency. And we can see that there are fewer lines now, but this will likely change as the bulb continues to warm up even more. And on this end, it seems as though that the camera is measuring the brightness. Now I will pause the video and bring the bulb closer inwards, or that is move the coils inwards more so that to hasten the effect. And you can see already that the lines are starting to vibrate, so actually let's let that happen. We could also hear that there is a vibratory action, a high-pitched audio oscillation emanating from the bulb, which indicates that the oscillating, vibrating lines occurring in the bulb are also simultaneously vibrating the air molecules around it at a possible frequency corresponding to the operation of the bulb or the setup as.
Okay, I'm going to pause it there because I can't play the whole thing. Real quick. I'm going to drop the link right now in the chat, guys, for everybody who wants to go check that out. It's Griffin Brock's channel. He does a lot of Tesla coil stuff, and he's reverse engineering a lot of Tesla's work on stuff. And he has a Tesla coil X-ray that he does, and it's in cold electricity. So definitely worth checking out his channel, man. He does awesome work.
Yeah, no, that's really, really cool.
Yeah. So, yeah, that whole thing, man, the separation, the vibration, he's up in the megahertz range. Yeah.
Yep.
That was something worth doing. I'm sure you're sitting there behind some kind of shielding or something, though.
Yeah, like I said, I think that between the UV and the RF coming off of it, it just kind of screams like don't necessarily want to be in direct proximity to it, but like, hey, whatever, man.
Anything in that megahertz range, man, you get kind of a weird feeling being around it. So,
hey, he made the video. We got to see it. Awesome.
Yeah. Oh, no. Hey, hats off to him, man. Congratulations, man. That was an awesome video.
Hell yeah.
So, that didn't look that hard, though. I mean, he had gas in there, and then he had a bulb, and then basically the megahertz, that's not hard to hit. So, not a bad experiment, man.
Yeah, the separation was the most interesting part of that to me.
Yeah,
because it definitely had, structure to exactly what was going on. I don't know if that's elemental separation, because he said it was mercury and something else, I thought. Or if that was, charge separation. Be interesting to know if it's charge separation that's leading to that. Definitely, like he was saying, the camera in that context like picks no justice. It's just not. That's how I figured right off when he said that it was white, but it was purple because the mercury is putting off in the purple spectrum. When you couldn't see it being purple and it was white, you knew that outside a camera's visual range to detect the UV was being produced, and that's the dangerous stuff. That's why I said that's not a safe experiment.
Gotcha.
Because like your eyes could see, into the UV spectrum, just not most of it. Cameras could pick up a lot more, but once something just appears blown out in white with nothing in the spectrum, you're just outside. You're outside the range. You're high, very high. So throwing that out there.
Gotcha. Well, it makes sense. Makes perfect sense. I just like the way it separated, and then the lines started to vibrate a little bit. You know what I mean?
Yeah. Yeah. Society just kind of dropped that in there to the what do you say? There we go.
Right here?
Yep. Heavier elements sink toward the cancellation points in the standing wave. Yeah. The ions, okay, out of sequence, but the ions and atoms do separate. There's an atomic centrifuge modeled off the idea. Yeah. There you go. And that's exactly the charge separation that you would need. That it starts acting. It would have to start acting electromagnetically at that point, sort of like a monopole would. And then it starts like delving into that. I don't know if you could find this video, but it was the video of the magnet arrays where you have the oppositely charged magnets. Oh no, I think Ashton showed that. It wasn't something we circled out. So he showed an experiment that was actually interesting. It had to do with electromagnetic locking, right? And it was a bunch of magnets that were situated with one pole facing on the outside of an array, and then a magnet of the opposite polarization in the center, right? Then if you took another magnet, right, and you moved that array toward the other magnet, it would reach a point of equilibrium where it's both being attracted and repelled at that equal state. So no matter where you move the array, the magnet would follow because it's in a lock situation, which makes sense. That's exactly how like a electromagnetic, monopole sort of would act.
That sounds
maybe
cool, man.
It's not really a monopole. It's just charge separation rather than it having a traditional north-south, it's one polarization on the outside and then the other charge being centric. Yeah, it was interesting.
Yeah, I'm sorry I missed it.
I mean, it's...
Yeah, I wish I would have watched it, man. I've been busy this week. I'll have to go back and take a look and see where he put it. Do you know if it was the last couple of videos he did?
Yeah, it was in the last. I think it was on the one this week. I'll find it and I'll send it to you.
Oh, thank you.
Yeah.
Yeah, sorry, man. It's been a long week, brother. I was up this morning early doing PDFs, and sometimes when you get to those, they don't let you highlight it, so they lock you out of it. So then you got to put it on Google Drive, and then get it to produce the text to Google Docs, and then you got to take that and put it into your AI software, and just a whole bunch of steps that suck to get 7 pages of information.
I know. Yeah. Well, for what it's worth, I can't wait until you get the hundreds of pages that I sent.
Oh, you see. Now that wouldn't let me highlighted it, so it was a straight transfer. So I'm getting through that book.
I think that when those go up, I think our audience is really gonna dig listening to those, man, because
I want to put them all up together as one book, not separate them, because it's
okay, cool, man. Yo, that's gonna be an epic then. Isaac Bensov is the man.
Yeah, so let me see if I can. Do you have the titles right off of hand and which ones they were?
Yeah. Chasing the Wild Pendulum and Cosmic Book.
Yeah, I think I was working on the Cosmic Book first.
Nice.
That's the one I was on, yeah. So, yeah, interesting reads, man, as far as I've got with them, because you have to listen back to everything and make sure it sounds right. So,
Yeah,
Yeah.
he's entertaining too. I like the way that they're written because they're not dry. Like he's got a little like sense of humor about him. So everything's like kind of lighthearted. Then he explains everything to you like you're an idiot, which I love. So I'm an idiot.
Well, that helps. I like that.
It does.
Yeah. Simplest form. Yeah. No, that's going to be really cool, man. Yeah. I kind of hope that channel grows a little bit because it's going to go right on the podcast channel because people listen to that in their car. You know what I mean? So
yeah,
that's where I put all the Tesla coil stuff when I go to do Tesla PDFs. I put it all in there, and then I put it on my Patreon, stuff like that for people to enjoy. And man, you wouldn't believe how much information's in one of these things once you start breaking it down. Because I have to, when you do it, you have to read it first and take out all of the little slashes between each word that's, from one thing to the next as they put it in there, which are a ton. Then you have to make sure that they didn't transfer any of the numbers, the coding numbers on the outside that goes with it. All those have to go away. So I literally read this stuff like 3 times, and then I listen to it in AI to make sure it hits the right points as it goes to the video to go on the right screen. Like, so if you're following along reading it, it says the same thing in the, yeah.
It's a ton of work. There's a reason that there's very few channels out there that actually do that, and there's channels dedicated to actually making everything into an AI audiobook and so on and so forth. But, I think it's great because I love to read, but at the same time, I'm also preoccupied. So putting on, just Audible or, one of these YouTube read alouds, that works for me if I'm preoccupied doing something else. I like killing 2 birds with 1 stone.
Well, yeah, I like putting it on when I'm winding coils and stuff.
Yeah.
I mean, if I'm not rocking out the AC/DC while I'm winding coils, I'm listening to an audiobook. And it's the fastest way to get something, you know what I mean? While you're working on something else. Because I don't have time to sit down and read, man. And it would, it would take like a million monsters to get me to read one book. It literally, I get to the second page and I'm done. I'm literally done, dude. I can't read anymore.
All right. Well, to hold up my end of the bargain, I think what I'm going to do is I'm going to get a couple more songs together for us to amp things up a little bit, and then we could put together your theme song, my theme song, our show's theme song, and all the rest. We could put together like a soundtrack,
There you go.
Try to make it fun.
Oh yeah. Well, I think you guys got one for Sean, so we can get that one going when I start playing that during the intro. We have our Saturday one. We have mine, and then you got what, 8 more put on there, 6 more. What do you think?
I think so. Yeah, just get like a nice 10 to 12 tracks together. There you go. Have it. Now you'll have something to play in your car.
There you go.
Billboard status.
So funny, I go to the park and I'm rocking out the old men's builds, or you know what I mean?
Your theme song's on point, man. I love that theme song.
I wish I would have wrote like 2 more paragraphs to it. You know what I mean?
Yeah.
That would have been awesome. How does a aluminum plate cover hover of a coil? Eddy current. But you have to have a strong enough coil underneath it. So get ready to push some amps. If you get an amperage coil, put it in epoxy if you can to reduce some of the heat or something like that. But yeah, you're going to basically be smelling that coil the whole time, depending on how much aluminum you have. But that's how you do it. It's eddy current. Aluminum hates magnetism. So, sorry. You can do it the opposite too. You could put the magnet on top, the coil magnet on top, and then the aluminum plate on the bottom. Get a nice thick aluminum plate. Then hit it, and it'll go up. So, or you could just create a magnetic field and then put another magnet up, and you get levitation that way. I was doing that with scissors, screwing around, man. It was kind of like, I say the bifilar belt is more like a maglev coil in the way it's designed, and it builds out concentric rings, right? Well, if you build it bigger and taller on the ring, then it's more like a maglev design. So then you have that one, and you put an outer one to it, and it'll hold everything right in the center. And it'll stay right there. And then if you push it, it'll come right back to the center. You push it, it goes right back to the center. Those coils are awesome, man, but takes a lot of time to kind of build them out. So, yeah, AC/DC too. I rock AC/DC all the time. A little bit of Metallica in the background, bro.
Yeah,
Which is funny.
Like, for some reason, no matter when I hear them, it just reminds me of a strip club I've never been to, because like I haven't really ever spent like enough time in a strip club, but like I just can't rid myself of that vibe for me. To be real.
Well, isn't that song "Shook You All Night Long" just about the nightclub or strip club?
I mean, I know all their hits, that's for sure, and every single one of them strokes me the same way. It feels like I should have like a fistful of dollar bills. Although in this economy, more like a fistful of 20s, probably.
Yeah. Oh my God, dude. That reminds me. These days, man, she's got the biggest balls of all. That song that they do. Yeah. It kind of fits with the days today, huh? Maybe not back then.
You'd be lucky if all she got is big balls. She got the meat swinging too.
They turn in the big hand on the clock.
Christ.
Oh man. I just laugh about that, man. How times have changed.
Yeah, for real.
Oh, what's going on, Negres? Yeah, and he's got a cool wine bottle coil. Have you seen it? He's got like probably like 20 of them by now. I enjoy each one he does. So he just found another one with some thick wire. I believe it was 20 gauge or something like that. Nice copper wire on it. Nice. Yeah, got the rods down the center, man, working it. Got those TV transistors going, if I'm not mistaken, those big ones. So they're like, 1,600 volts and 200 amps or something like that, something crazy. So,
yeah. Someone was just talking about waveform. Who was it? We got Ian.
He said no eddy
wave
current.
Waste of energy, sawtooth more efficient. Depends on what you're.
Hold on. I can tell you it's eddy current. You can argue all day. I can tell you that. That's the only way that whole thing works. Sorry, go ahead, Joe.
No, I was saying, well, that depends on what you're trying to achieve, because a square wave, by what it is like it's alternating pulse wave, really, on both sides, plus minus, plus minus, plus minus. The line that connects them is insignificant. Sawtooth has a ramp, so depends on what you're looking for, and there's a lot of flow properties to sawtooth waves in certain geometries that could be really effective.
So funny, dude. Okay, so you play with it, and I just recently did this. Anything that jumps up real quick and jumps right back down, pulse wave, square wave, sine wave, sawtooth wave, any one of them the magnet will respond to. Okay? Let's just be clear about that. Every single one of them they respond to. Now, how much and the duration of it is all it is. That's the only change that you're making. Okay? Sawtooth is basically, it hits a single point and goes straight down, right? A square wave goes up, stays, and then comes down. A sine wave gets up to it and then cruises back down, right? It's not that difficult. A pulse wave just does almost like a square wave does, and the same thing. You pulse for a certain duration, turns off. It's all about hitting that value right there and making the amps pump into it at one time. That's it. You can make any one of them respond to a magnet. I could go through my dial over here and do it. It wouldn't even be hard. So, oh man. Yeah, AC causes vibration. Well, yeah, it does cause a lot of vibration. I won't disagree with that. But you could still get it to respond if you hit it hard enough. So.
Yeah, well, anytime something's just like not exactly in phase, what do you expect?
Yeah. Well, hey, look. I don't know why he's arguing. I'm not redefining physics at all. I'm just telling you the truth. That's what I came across when I worked on it. Dude, I just did a bunch of videos where I played with the magnets. And I hit every single one of them, man. I was just going right up and down the thing. I got that sucker.
Yeah, I don't know that anything that we just said was inconsistent with accepted physics. I mean, if I'm wrong and you want to elaborate on that, by all means.
I don't know, man. Eddy currents build up inside of things. You don't have to have them in rotation. They naturally rotate. And then if you just take a rotating magnet that you put on a disc and put it over top of a new aluminum disc, well, that disc on the bottom will start spinning. That's the way it works. It'll spin with it.
Yeah.
So,
oh,
yeah.
I don't want to get too far into it, but this week we opened up a can of worms on laminar flow. And I think that deserves its own episode in onto itself, because you got to remember that when you're talking about anything electromagnetism, it really comes down to hydrodynamics. So being able to identify certain specific stable flow patterns that are self-contained, like laminar flow patterns, is critical understanding when you're building out these different fields. If you want you want layering effects, if you want compression effects, because the whole point is to keep it from interfering with everything else. It has to be unbroken and in onto itself. So
you see, I think I get a lot of laminar flow in the morning, and then towards the end of the day it goes into tendrils.
Yeah. Oh, that's your age showing, bro. You just had a birthday. It doesn't get any better.
It's getting worse.
That's it.
That's a vortex math for you.
You just gotta rotate the weenie a little bit. So you know what I mean? You gotta give it a little spin, like rifling, like cock rifling.
Oh man, like some days
we've fallen apart. It's gone. The episode is done.
Sometimes, man, I can't hit the side of a barn, bro. It gets bad when you get older.
Okay. Time energy. I'm not one to ever correct anybody, but torsion field. Okay. Just because I love torsion, I need to comment on it.
Okay, go ahead.
There's no real torsion field, because torsion is a multi-field interaction. So it doesn't really produce its own field. It's just more a multi-field interaction. I don't know. I don't know if I'm saying that right. Like in my head, it's making more sense than it's coming out of my mouth. But yeah.
Okay. He says the torrid. I don't know what you guys are talking about. I'm kind of lost. I'm still stuck on the flow pattern. What did he say here?
Yeah, I really can't read it. Sorry. As a metaphor, gentlemen, as far as the spark gap, think about a rotary engine that was in an aircraft in 1940. Then look at the way that you generate the spark from the circle. So rotary engines, they work off of, I don't know the name of the shape exactly, but it's sort of like a triangle with bent edges, right? And it works off of different cycles. So it only, it's got the 3 cycles that you would generally have, where you have like a spark and combustion and an exhaust and an intake, but it works in like an asymmetric geometry, so to speak, that like coincides with the cylinder rotating inside of the combustion. So I'm just trying to put that metaphor together as far as how the spark gap works in that rotary. Excuse me 1 second. My dog is eating something and I'm going to probably be upset.
I have no idea. Doesn't mean.
What are you doing? Yeah, you're in trouble. Yep, you're in trouble.
Doesn't mean Winkle, huh?
Oh. Yeah. He's lucky I love him. He's lucky I love him.
Wow.
Yeah, his dog toy got stuck in like a bed sheet that I just washed because he decided that my neatly folded laundry didn't have to be neatly folded since I neglected to put it away before I came on today.
Oh.
And he made a mess of it and decided to lay on it. I let that go. That was a lot earlier. I let it go. I was like, whatever. But then his toy got stuck in my bed sheet. And then he decided that the way to get the toy out of the bed sheet was to eat through my goddamn sheet.
Oh.
That it was stuck in, and I heard tearing, and I was like, you are in trouble.
Yeah.
It's okay. He's not really in trouble. It's my fault for not putting the crap away. Like, he's a dog.
Yeah, new bed sheet shopping you're going.
That's fine, man. The only thing we have in this town is Walmart, so I'll just go to Walmart.
There you go.
For $20, I'll have new bed sheets.
Well, pretty much how it works, isn't it?
Fucking asshat. Fucking asshat. Best dog in the world. Total asshat. Now, what were you saying before I literally heard that tearing?
I don't know, Joe.
I don't know either. Something about cock rifle.
Huh. Oh, yeah. On that note.
Oh no, we were talking about that combustion engine. I did the rotary engine. I don't know what metaphor that was trying to relate to.
I don't know either.
Yeah, but I'm curious. So if you want to put it in there, I'll catch that.
Let's see. The first rotary engines ran like two-stroke bikes. Okay. Interesting. Oh, well. All right, Joe. It's been fun, man. I'm hoping Sean will be good for next week. So
yeah, get me off the hook. You know how I look forward to my time pissing you people off and talking about irrelevant shit.
Oh, now we're going to talk about flow patterns. Oh, man. Are we doing that on Friday or are we doing that a different day?
We can do that on Friday. I think that we could talk about different flow and interference hydrodynamic patterns. I think that's a great topic, something I love.
Yeah, take your camera out there with the hose. I don't know if it's warm enough, but see if it'll.
For me, that's not going to be a practicality. We'll have to pull up some videos on laminar flow. But what I can do, okay, is I could take some nice HD videos of the lake by me and stuff like that. I already have some, but I'll get some more, or the river by me. And we could see some like really interesting flow interferences and stuff by looking at the water, and just it shows you exactly what's going on with the field geometries, like plain simple. Just is what it is. You look at a good flowing water source and you could just learn so much right off of that.
Yeah.
I actually found that I think I sent you the video. Don't look for it now though, but I'll send it to you again so we could look at it on Friday. But there was this one point in the creek by my house where it was like a little waterfall. And the way that the geometry of how this water was flowing laminarly over this one rock. And it was slipping under its own self and coming back. And it was coming back in a scalar form, okay? Like where it picked up all the energy that it's compressing down, got redirected back toward itself in a sustaining loop where it was actually riding up on itself in a reverse flow. Okay, so no matter how powerful that was, it reached this state of equilibrium coming down, only to be amplified, come back at itself in a positive with a positive amount of force, enough to fight against itself and cause the downward slip. So these are things that you need to look at, identify, realize, because these are the critical things. That in itself is free energy, if you want to think about it that way. Like, that's the whole the entire point, is to have it actually have an outcome that is of itself and greater than itself. Right? And it was right there.
Nice.
Yeah. Right? Creeks flow one way, except for this one spot that was 18 inches long and 10 inches wide. In that one spot, it flowed the other way.
Well, that's good.
Yeah.
Oh, yeah, we have to see that in some HD, man. That's awesome.
Yeah, and I have some good footage, and I'll get some more if I can between now and then.
Right on, guys. I want to thank everybody for watching today. Thank you, Joe, for coming in and hanging out with us. And thank you guys in the chat, man. You guys have been awesome.
All right. Peace and love, folks. See you on Friday.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.